All right, well, it's time, so let's go ahead and we'll get started. So tonight we are talking specifically about the swing arm, which we drew up last week. And this is for a 6-inch diameter hose. I actually put a 5-inch diameter hose on this system, so this is oversized. And it's actually a little bit longer than I really need. And so I will probably build another one for a 5-inch hose, so it fits this one perfectly. And I'll shorten it up a little bit too. So one of the things I want to show you is if you take the drawing I have here and you want to make it longer or shorter, depending on how far away from the wall your machine is, we can scale this. And I'll show you the technique we used for that. So I'm going to go ahead and share my screen here real quickly, and we'll just open up the Spire. And okay, so I've put this on separate layers. So at first, this is my assembly drawing that I just kind of figured out how far away from the wall and how long the arm would have to be. And again, this we drew up in Aspire, which it does not have the tangent circle controls. And so I chamfered these, put a fillet on these corners, and so they're all the same. And it looks cool. I like it. I did it the other way before, so it doesn't really matter. But in Aspire, this was the way to do it. And then I took all of those and I built on the actual 4x8 sheet. I laid out all the parts. Now I took our drawing from last time and I have updated it. I told you I would add some holes in here for the dowels and the mounting holes. And I added the dog bones in here so that we could set the pieces in. And I've kind of cleaned it up and got it all ready for you. And I actually added one more piece. If you look here, there's a cap on the end of it instead of open like the one I have up here behind me. It's just open. But the first one I built had a cap, and I like that. And so I added, this is the cap right here. Well, this is a nice mouse. And these are the screws to mount it. And I also added some holes down here that we can, I used the little zip ties. And so I can zip tie the hose to this right here at the end to hold it up against that piece to kind of secure it. I also added holes back in here into this piece and in this piece here so that you can zip tie the hoses in at the beginning and at the end, and then we just let it sit on the dowels, which I don't have on my assembly drawing, but over here you can see they're right here. Okay, so the challenge that I had was making this easy to extend this longer or shorter without redrawing the entire piece. All right, so here's what I did. I took, and if I click on this, you can see that I have cut this into two parts, here and here. The same thing with this arm, here and here. So the way that I did that, maybe I just draw something up and show you how it's done real quickly. If you're brand new to this is kind of an advanced technique, but let me show you what I did. So I'm just going to select this, and I'm going to go into node editing mode, which is here on the side, or you can just press the letter N, and you can see I only have the 4 nodes, so I can adjust those nodes if I want. But what I did was I drew a separate line where I wanted it, like so. And then I took and went into node editing and came in here, and you can try and do it right here, but it might be easier to just put it in here and say insert a point. And I can do the same thing down here. It doesn't matter where, I'm just going to say insert a point. Or what did I just click on? Insert a midpoint. Okay, so the midpoint is right here, which is not what I wanted. But you can move those points. So I'm just going to drag it back here so it snaps to that point, and I'll do the same thing here. I'll grab that node and slip it back here. So now I don't need this any longer. It was just a construction line, so I'll go ahead and delete it. And you can see now I have these nodes. It's still all one piece, but I took and right-click on this now, and I say cut the vector, and then I come down here, right-click and say cut the vector. So now I have I'll turn node editing off, and you can see I have this piece and this piece separately. Now, the reason I did that was because if I scale this part, I'm gonna anchor this in, and I'm gonna scale this in longer or shorter. I don't want it to scale this circle, or down here. I don't want it to scale any of this part right here. I want this to stay the same. So again, I put a node right here at this point. Select that again. And you can see they're straight up and down right here. So at the end of the flat, I added nodes. And it's the same thing down here on this one. All right. So now I can scale this section down here without scaling this back section. Okay. So again, just to recap, I added a line up through here, and then I added nodes. Inserted points is what they call it. They're nodes, but they call it insert a point right there and there. And then I cut it. So I've got two separate pieces. Right. Now, what I can do, the other thing that I did is I've got these circles right here. These are 0.51 inches, so I can put a 1/2 inch dowel in here. And I know that when I scale this, these are going to deform, okay? Because the height's going to stay the same, but the width is going to get narrower. So I drew these little crosshairs in here so that I would have a point right there. So I can come back and add a circle at that point, no matter where it goes. These will distort, they'll be no good, but I'll still have that center point with that crosshair in there. So I did that on all of my circles. And what I did was, I'll just kind of sketch some in here for you real quickly. I'm going to Control-C, Control-V, and I'm just going to move this one down a little bit, right? And I had all of them along there, so I just took a line and I drew it, through them, whether it was on the angle down here, you can see these are on an angle, or straight up here on the top. And then I also drew a line just from this quadrant to this quadrant, and hit the space bar, it'll start a new one, and it'll turn to a little square when you get to that quadrant, so it'll snap perfectly. And then I just took my trim tool and I unchecked the rejoin. I don't want to rejoin anything. I just want to cut these. Okay. So that's how I added those crosshairs into each one of the circles real quickly. Now I'm just going to delete these because I don't want them. All right.
So Tracy, one of the things you could do also is if you are using a drill bit, you could leave those holes and let them distort. If you used a drill bit, then it would just go to the center of that hole anyways and drill the hole.
Oh, good thinking. Yeah, absolutely. So if you had a drill bit, in this case, it would be a 1/2 inch drill, then you could do that. And because when you drill a hole, I'll just point this out real quickly. It doesn't matter how big this is. If I create a drilling tool path, let me just move my face out of the way here. If I create a drilling tool path based on that, and I select the cutter, in this case, I'm using a 1/4 inch end mill. This is a flat cutting plunge style end mill, so I could actually do this, but I could choose a drill bit as well. And it's going to drill right in the middle of that circle, no matter how big the circle is. So let me just preview that and bring this over so you can see it. Okay, so that's the size of that's all distorted. I need to increase my resolution, but that hole is the size of the drill bit or the bit, not the size of the circle that I drew there. So that's a good point. I wasn't aware that you could distort a circle and do that. So maybe I'll try that real quickly. I'm going to take this right here and just, we'll distort it pretty radically. And now let's go back into this drill, and that one's selected, and let's just calibrate it. And I'm going to move my face out of the way. I put it down here in the corner again, and let's preview it. And sure enough, it drilled it right in the center of that oval or that ellipse that we distorted that. So that would work if you wanted to drill it. Okay, I don't have a 0.51 inch diameter drill, so I'll use a 1/4 inch cutter and I will machine it out. Drill is going to be faster, obviously, and if I was doing production, that's the way I would do it. But because I'm only cutting one piece, I decided I'd use the same cutter to do everything, and so I'll have to redraw those circles.
So one final editorial on that, Tracy, is you just proved that if you have any object and you select it, it will drill to the center of that object.
Exactly. Yeah, that's exactly right. That was pretty awesome. So I could drill to the center of this object, or even the center of this this piece here, or this piece here, or anything that I have, you could drill in the center of that, even an odd shape, which is awesome. Okay, so let me show you one other thing I did here real quickly. I went into my layers and I created one called rabbits. So if I turn that off, I can see just the part I'm going to cut out. But if I turn that on, then I can create a toolpath to machine the rabbit here. Now, you notice that the rabbit is a little bit longer and a little bit wider. And I made them an 1/8 inch wider, an 8 inch on each end, and an 1/8 inch taller in this case. So it'll cut right to this edge where I want it, but it'll overlap the part. And so because I'm using a 1/4 inch drill, or not drill bit, but rounder bit here, that's an 1/8 inch pass. So in other words, it'll clean this corner up on all the corners. And I did the same thing here. You notice this goes past it, so it'll cut a clean corner here, because if it ended right here, I would have a small radius right here from the bit. And the same thing here, I didn't want a radius here, so I overlapped them. And then on the inside, I put the dog bone here, and of course, and all those other ones. So that's how I prepped this up. And I did add, again, this one piece right here that I'm going to cap the end. All right. So now let's go ahead and do some distortion and scale it and show it. So if I turn these off and I select everything and scale it, these would not be scaled. So I'm going to leave them on. So I've got that layer turned on, the rabbit right here. So I'll scale everything. And I'm going to just click here, and I'm going to drag this out. Remember, if you go left to right, everything inside of the frame will be selected. If you go right to left, everything that it crosses will be selected. So I intentionally went left to right so that I could grab just the elements that I want. Now, there's a few things I don't want to scale. For example, there's this hole right here I don't want to. So I'm going to hold down my shift key and click on that to deselect it. So I don't want to distort any of this. I don't want to scale any of this. And then I'm going to come up here, and I don't want to scale this piece or these holes. And so I'd have to do that on all these parts. See, I had one there. And let's see what else. I'll actually, I want to scale the dados as well. So let's go ahead and select those. Okay, so now everything from this point forward is going to be scaled, but everything back here is going to stay consistent. Now, there is a tool right here that you can click on to transform mode, which means move or scale. But you can do the same thing simply by clicking everything that you selected, click on it again, any one of the objects, and it puts it into transform scale mode. Okay. Now you'll notice there's a little node right there. And when you mouse over it, we'll grab that, and I can scale this. Like so, I can make it shorter or longer. So what I would do, to be honest with you, if I knew I wanted to shorten this by, say, 6 inches, then I would draw a line. This is the way that I would do it. I draw a line right here, and I would move that line into transform objects. There's a move selected object, and in the x-axis, I'd say relative from where it's at. Let's move it. Well, let's go maybe 5 inches. Okay. So let's say we want to shorten this arm by 5 inches, or we want to lengthen it by 3 inches or whatever. Now, if I made it a lot longer, I'm going to have to regroup all these things and make sure everything fits. And if it's long enough that everything doesn't fit on one sheet, I'd have to move some of these components to a second sheet, or somehow rearrange them so I could try and get everything in. If I took and flipped this one here, then I could squeeze these together. You see how much material we could pick up here, so I could throw some of these parts in here. So there's some things that I could do to to make it fit better, but I just laid it out simply like this. All right, so now we've got that line. Let's do this again. I'm going to come back to like so. Now, the reason it didn't select the rabbit, this rectangle, is because it was not contained inside of the frame. So I'll go back and reselect that. I'll deselect this circle and this circle. And down here, again, I'll deselect these items. And you could take this and say anything inside the frame, again, going left to right, anything inside of it will be selected instead of one at a time, like so. So we're ready to scale all of this. Again, all I have to do is click on it a second time. I could click this icon over here for transform mode, or I can simply click on it a second time, and that will show up. Now, if I grab this corner down here, it would scale from the corner, so it gets narrower and everything. We don't want to do that. That's why I grab this one in the center, so it'll only scale from this point, and I'll just drag it over to, it snaps to this line. Okay, so now we've made it all 5" shorter. And at this point, because I didn't scale these, I didn't want to, I'm just going to bring this in like this, and I'll just use my arrow keys to, position it where I want it. If I want to get real critical, I draw a line from here at 45 degrees out, but I'm just going to line that up, and that looks pretty good. So, I mean, you can get really critical here and draw a line at 45 and snap that to the line, but I'm just going to just move it in like that. And again, this line is just a construction line, so I'm going to erase that. Okay, so now it's going to cut everything out. It's just 5" shorter than the one that I drew. So your problem here, though, is that we could try to cut this out. These parts are not connected. So at this point, I'm going to turn off my rabbit, just get him out of the way. And I'll just zoom in here. I could now select this and select this. And I could do the same thing with all of these components, and then just use the join tool right down here. And when I say join this vector, okay, and it's probably, the tolerance is probably too small, so I'm going to make it a little bit bigger and see if that'll work. And it's saying no. And I'm not sure why. Okay, I'm going to make it even bigger. That's funny. Why would it do that?
There's an overlap on the two of them.
There's, oh, probably right in here. Oh yeah,
Yes.
Sure enough. Okay, so what we'll do then is we will use another tool. So this is join vectors to a straight line, or vectors with a smooth curve, or move the points so they're together. So this would be the one to use, because if this one overlaps the other one, then I would take this guy and click on that. And now they are one piece again, and it simply took the 2 points, one was longer than the other, and pushed
You got
them
to do
together.
it twice. You got to do it twice.
Got to do it twice? Oh, because we got one down here as well? Okay, so let's go ahead and do this one again. Oh yeah, sure enough, and that connected that one as well. So I would do the same thing with this. And I'm just going to zoom in here and see if we are overlapping. Sure enough, we're overlapping here. So there's two ways. I can just say join those two together, or if I wanted to, I could double click on this and I could grab that point and move it back to here. But it's probably easier to grab these pieces and just say, and I could do the same things. No, let's just do that one right there. So I'll do this, and we'll do it one time and twice, and that should have connected it. And then we'll do the same thing here. Okay, so now all of my pieces are connected so that I can program this now to cut this all out. All right. I forgot to mention one other thing I did. I added in these holes here for mounting this, and of course added in the rabbits that will cut out. And I didn't like the way this came to a complete point, So I trimmed this back. So this was 1/8 of an inch of material. So I wouldn't have a, point in the material. And because I cut that back, I also cut this back. It was out here. I moved it back and I found 7/8 of an inch, 0.875 was enough to give me about an 1/8 inch flat right here. And I like that. So I did some adjustments from what we drew last week, but I'll save all of these. And I've got it saved, back to the other one. So what I'm going to do now is I'm going to say file save as, because I don't want to overwrite that one. And let me go into my file here, projects, studio dust collector. So this one's called the 6-inch dust collection swing arm for the workshop. And swing arm, I'm just going to put here, I'll just put -5 for the workshop. Okay, so that's the swing arm, -5 inches. So I've got a copy of each one now. The original, which is the one I'll post, and then you can follow these instructions if you need to make it longer or shorter. Okay, any questions to this point so far? Okay, then the last thing, of course, is just programming, and this is going to be, fairly simple. The first thing I'm going to do is erase this drill because that was a sample. We don't want that in there. All right, so I would not cut the parts out first. So I would take all of these.
I have a question.
Yes, please.
When you resize like that, what do you do with the strength? That's an arm that sticks out there quite a bit, even though it's not carrying a lot of weight in itself. There's quite a bit of leverage. Yeah,
I've got this, pretty wide, and we put it, if you look at the, I'll show you what we did here in the assembly. There's actually a 1-inch dowel that goes down through here, and I did cut an 1/8 inch plastic washer that fits right in here. And so this stays it swings really, really easily. And because we've removed so much material with these cutouts, this is pretty lightweight. And if I extended it out a foot, I still wouldn't have any problem. The one I've got on here now is about, I would say, probably 6 or 8 inches longer than what I need for this table. I didn't know where the machine was going to be placed when I designed and built it, so I made it longer, but it's too long, so I have to have the hose a little bit longer. And so in the last class we showed that if this is the wall right here, we want this end to be about 16 inches from the, well, let's say the arm was up here. Let me erase this real quickly. We don't need this. I'm going to just grab this guy, copy it and paste it, move it up here and rotate it like so. Oops, not that far. And so I would, and what I'm going to do real quickly so I can make sure I can select this easy is I'm going to group these. So there's an icon here, edit objects that says group them. And if I click that, you can see they're not dotted any longer, it's solid lines. That means if I click on any element, it chooses the whole thing. The reason I did that is because if I bring it down here like this, I've got all these elements and then I'd have to go select each one of those to move it or get rid of it, which would be a nightmare. So I grouped them so that I could place this where I want. And I found I would want this if I was to double click so I can move it. And I grabbed this end here and I brought it all the way to this edge. Then I wanted it back about 16 inches. So I would use my move tool right here, and I'd say relative in the y-axis, let's go 16 inches. Okay. And that's where I want the end of it. Now, this says that this from the wall, you see how far away from the wall it is, that table? Quite a bit. So I would draw, if this was, I think my table was 39 inches away. So I would draw a line along this edge. And then I would use the move tool under transform, and in the Y, I'd go 39 inches. Oh, that it's actually pretty dang close. Okay, so this one is designed pretty much at 39. It's only off by, you can see, 3/4 of an inch. So I wouldn't probably worry about this. I'd probably leave it. So this was set up for 39 inches and left 16 inches here. And so as it swings, the hose is, has to reach back here. When it's in the middle, it has to reach back to this corner. When it's over here, it has to reach out to this corner. So that's about right. Okay, so you can kind of play with those. And again, by grouping all of this, and I can group all of it, I'll group it again. Then if I click on it the second time, I can just move the whole thing out of the way. And I would probably move it to a new layer so I can cut it off. So I'll click on move to layer, I'll click on new layer, and I'll call this the swing test. Okay, or something like that, so that I can simply turn that layer off and my assembly off so they're not in the way. All right, so let's go ahead and program this one. But if you cut the exact one that I built last time, you would have to make sure you join these back together and program it from there. You wouldn't have to scale it to get it to the length you want. So let's go ahead and program. And to start with, I'm going to turn my rabbet joints off. All right, so I'm going to select this guy. Well, no, we're going to cut out the parts first. If I go right to left, anything that it crosses gets selected. If I go left to right, only what's inside the frame will be selected. Okay, so we'll cut all those out, and then we can do the same thing here. Cut all those out, and that. No, we don't want to cut this out. I'm sorry. Those are only an 1/8 inch deep, so we'll do those separately. So I'm just going to cut out these. We can cut out these circles. All right. So we're going to cut all the way through here to remove all of these parts. Oops, I got one more.
slope.
Yeah, there we go. So now I'll go ahead and cut these all out, and we'll use the profile toolpath to do this. And I'm going to use a 1/4 inch diameter end mill to do everything. All right, so I don't have to change the cutter. So when I cut out the rabbets, it's going to take a little longer, because if I used a 1/2 inch or a big surfacing bit, it would go much faster. But I'm going to do it all with an 1/8 inch quarter, so I don't have to change the cutter at all. So this says it's going to go 3/4 of an inch deep. Okay, and that will cut all the way through. If you wanted to add, if you had a spoil board and you wanted to add maybe 10 thousandths, I'd go 0.76 in the depth right there. Let me move my face over here out of the way on my screen. Okay, so I'm going to go just 10 thousandths through to make sure I cut all the way through. This is plywood and it's finished ply, so I don't want to leave an onion skin, because then it can, chip or peel or be a pain in the butt to finish. So we make sure we cut all the way through. And you can see here, I have chosen, this is a 2 flute. Oh, this is the 1/2 inch. This is not the one we want. So let's cancel that. We'll click on select, and we'll use an end mill, and I'm going to use a 1/4 inch, 3/4 of an inch long. All right. And
you can pull the left side of that out to see all the.
yeah, absolutely. You can pull this guy here out, and there's actually a way to go into your settings and save that so it remembers it. I don't remember the exact thing to set, but I think it might be under edit or it might be under file or whatever. But it'll keep this open this wide to make it easier. So next time you open, you don't have to scale it out again. But we're going to skip that right now. I'm just going to grab this cutter. I'll make sure it's 40% step over. And we have a pass depth of 1/4 of an inch, which is acceptable. That's fine on this guy. And you might even push it a little bit, with a bigger spindle, you could push it deeper. In fact, I've seen it cut full depth, 3/4 of an inch in one pass. But we're going to be a little bit more conservative here. We'll do it in multiple passes, just because if you got a smaller spindle or whatever, you want to take it a little bit more easy. So we'll be cautious here. And down here, I'm going to tell it has 2 flutes. And so that tells me that it's only a 2/1000 chip load, and that's at 80 inches. So I'm going to push this up. We're going to go 150. Now, again, this is pretty conservative. I'd probably cut it about 300 inches on my 4x8. Okay, so on a bigger machine with a bigger spindle, I could push these numbers up. You can always adjust it on the fly as you're cutting as well. So we're going to program it for 150. Again, kind of conservative, but when you see that, it's about 4 thousandths of an inch, 0.39. So I'm going to slow this down to 16,000 RPM, and it calculates the chip load over here based on the RPM and the feed rate. So we're at about 5 thousandths chip load. Okay, and that's doable. We could actually push it up to about 8 thousandths and be fine. But, you know, so we could push it down to maybe 14,000. And that makes it 5.5 thousandths. And I could push this up onto like 180. And because I'm going to ramp these, I'm going to set the ramp to 180 as well. So now we're at 6.5 thousandths of an inch chip load. And that'll work fine. Again, we don't have to be perfect, but as Milo explained when he did his class on chip load, if you get the chip load correct, it's just big enough to where it's supposed to be in that range for this cutter, it can actually cool the router bit and make it last much longer. So I never really paid much attention to this, to be honest with you. I was pretty consistent. I ran at about 20,000 RPM and about 120 with our smaller machines and push up to 150. So my chip loads were always lighter, and consequently the bit would heat up and burn my bits faster, and I would have to replace the cutters. So you might want to get a chip load calculator and play with it, but I would probably push it up between 6 and 8 thousand, or you know, 6 and 8 thousandths of an inch. And here we're about 6.5. Milo, you're welcome to jump in here and tell me I'm crazy or I'm doing it wrong, because I know you know a lot more about this than I do. So if I screw up, just jump in here, okay?
Heat kills.
Heat kills, that's right. So that's why we want that chip load to be larger. And again, every bit, the manufacturer will kind of list the suggested chip load. And so you're going to adjust your RPM. This is a real side note, but I was just out in Colorado with Doug and Milo, and he did a class. In fact, Ron from Precise Bits had come over, and they wrote a program where they would create the same chip load, but they would adjust the feed rate and the RPM so that the chip load would stay consistent, and they would make multiple passes. And you can see, even though it's the same chip load, you can see the feed rate that gives you the absolute cleanest cut, and it's pretty dramatic. So this is something I'm not going to have an answer for you right now, you know, how to get the best optimal cut. Just something you might want to try with your machine, because it'll depend on your spindle size, and the router bit that you're using, and so on and so on. So this is way beyond the scope of this class, but just know that if you can get it into the right chip load, you can play with feed rates and do some test cuts and get it exactly what you want for this material. I'm going to use tool number 1 here, and we'll click select. And then, okay, so what we've got here is just going to take 3 passes. That's fine. We want to cut inside, not on the outside of the vectors. We're going to do a separate last pass of 15 thousandths of an inch, 0.015. Okay, and that way we won't have the witness lines of each pass, because the last pass will clean them all up. It'll cut 15,000. It'll cut all the way up to the line at 15 thousandths of an inch, and you'll be good. All right, and then we're not going to add any tabs here. Although you might want to. If you're using a 1/4 inch bit, you may not need tabs. But if you want to add tabs, click on here, and then you can go in to say edit tabs, and you can tell it exactly where you're going to put a tab on these if you'd like. Okay, I'm not going to tab this right now, and the reason I'm not going to is because if you use a down cut, which I use so I don't tear up the top grain, it's a spiral down cut, it will push the sawdust into the groove behind it, and that will hold the part in place. Right, so this works well. Now, just one heads up, these 1-inch circles here, that's a little small. And if you're nervous about that, I would not include these circles with this profile toolpath. I would do this as a pocket mill. In other words, it would turn this whole circle into sawdust. There would be no little piece left in here that could catch the bit, right? So that is a very legitimate way to do it. It's slower because you got to turn that whole plug into sawdust instead of just cutting around it, right? But just something to be aware of and something you might play with. Okay, in fact, I'm going to do that. I'm just going to deselect all these 1-inch diameter holes. We're not going to push our luck, because if the bit grabs that, it can bend the bit and cause all kinds of problems. So let's eliminate those and just cut out these bigger circles. We're not going to use tabs. All right, and we are going to ramp, and I like to use just a smooth ramp with an angle of 20 degrees. That's the optimum angle for ramping for pressure on your bearings of your spindle and the tip of the router bit. Okay, so that's the default that you'll use for this type of work. All right, so we've got everything in here set. Oh, go ahead.
Back to the holes, I understand why the 1-inch holes, but why didn't you include the 1/2-inch dowel holes in this?
The reason being is because I am going to use a different type of ramp for those holes. I'm going to use a spiral ramp, and when we do that, you'll see it. It's not going to ramp, you know, a 20-degree angle and then cut around and then a 20-degree cut around. It's just going to be like cutting the threads of the screw almost. You know, it's just going to continually spiral down as it cuts it. And when I'm doing small holes like this, that's the preferred method, not an angled ramp. That's why I did it separate.
Tracy,
Okay,
if you're using a downcut bit with 3 passes, aren't you cutting the chips a second time as you go through? On the second and third pass?
You're right. You are. You're going to put chips down inside there, and you're going to do a second pass, and it's going to possibly recut those chips and throw them back out the bat again. Most of them will be sucked up in your dust collection, but there will be some down inside the groove. And you know, again, you with the right size spindle and the right cutters and everything, you could do this all in one pass and eliminate all this. But I've done this 1,000 times, and this works extremely well. Okay, I might actually, to be honest with you, I personally would probably set this for 2 passes because of the size of the spindle, and do a separate last pass. And so instead of 3, 2, it's going to speed it up. That's the way I would do it. I feel comfortable with that. If you're uncomfortable, you know, make it 3, but 2 is going to work.
I've seen some stuff done where they do it in 1 pass. They just slow their speed down. And they cut it in 1 pass. Okay,
perfect. Right, so it's going to be called profile 1. So I'm just going to give this a name so I know what it's supposed to be doing. And we're going to say, I'm going to say cut out details or something. All right, and it says it's going to cut through, and it's always going to tell you that. It says the material is 0.75, you're going to go 0.76. I'm saying, yeah, I know. Okay, I'll accept that. And then it'll always bring up your preview, and just click on preview, and you can see. And if you want to, you can double click on these components, and they'll go away. And I just noticed I still have these holes up here from before, so I'm going to reset my preview and then preview this, and so those holes are gone because that was left over from the last time I did it. Okay, and if we want to, take the time to double click, you can get all these out. I'm not going to do it right now. We'll go on.
How do you feel about using a compression bit instead of a down bit?
Compression bits are great, but you're going to do it in 1 pass, or you can do it in 2 passes as long as your first pass is deeper than the upcut on the bottom, and typically they're about 1/4 of an inch. So in this technique, it would work. You could, but I'm not going to. The only thing is, I'm not going to ramp with a compression bit. I'm just going to plunge straight in and cut all the way out. Okay, because if you ramp, that where you're ramping down in, it's lifting and it's going to tear the grain right there where it starts. All right. But I like compression bits. We're okay with this without a compression bit. I use it on melamine, definitely, but on this ply, because it's backed, it's sitting on the spoil board, it's backed, so I really haven't had a problem with a downcut on this, this type of setup with this material. But a compression bit's perfectly legitimate. All right. I know a lot of people go to compression, go to a 3/8, gives it a little bit more strength. It has to remove more material, but there's trade-offs on that as well. And again, a little bit beyond the scope of this class, but it's doable.
What if you
All
ramped
right.
in from the center of your cut with a compression bit so you're down to the proper level when it gets out to the line?
Okay, so if you were ramping up here in the middle somewhere and then cut into it.
Yes.
You know,
Yeah.
there is a thing called a lead-in. It's called leads right here, and you can say add leads and straight lines, and you can say angles, but I haven't used this, and I don't know if it works on a closed vector or not. If somebody's got any experience, you're welcome to jump in here. But the lead-in, if it's on a straight line, you know, cuts into the line and then starts cutting along the line. And a ramping on a lead-in would work. I'm just not sure it'll work with these closed vectors, and so I'm just going to use a down shear and ramp the half inch. So all of those are perfectly legitimate.
It does work. You just have to lead in from the inside of your cut.
Okay,
versus the
let's
outside
go
of your
back in
cut.
there and, okay, so let's go back to leads and add a lead in. So we
Circular.
okay, we got a straight lead in, we got a circular lead in, and radius, lead in length, 1 inch. Now, do we know this? Is it going to lead in from the inside because we're cutting on the inside? Does anybody know?
Leads in from the outside.
Okay, I'm gonna just try this and we'll see what the toolpath looks like. One or more leads were clipped or removed. All right, so you can see the lead in right here. Yeah, this is actually here, and it's leading and it's doing the ramp, so it's doing this zigzag thing, and then in. Interesting. So I'm gonna reset my preview. I'm gonna slow this down, and we're going to select this and see. I'm zoomed in close so we can see if we can see it when it gets to this point. I may have slowed it down too much. Okay, yeah, it was too fast. I sped it up too much. Okay, again, you could play with lead in if you want to use, you know, the compression and then you could ramp in. I'm not going to on this one. I'm going to use my down shear, and we're going to take the leads out, and we're going to calculate that and save it. Okay, so now I'll zoom back out. I'm going to reset and preview it. So that's the way we're programming this one.
You're now doing this on a vacuum table, is that correct?
Yeah, I would do this on a vacuum table because it's you know, going to hold the pieces down. These will be held by, because of the down cut. It'll kind of put sawdust in these grooves, and that will act as a method of holding apart. The smaller the diameter cutter and the bigger the part, less likely it's going to cause a problem. And that's exactly why I took these circles out, because I didn't want it to, you know, catch the edge of the cutter and cause a problem. So these we're going to do differently. Okay, so I'm going to, but yeah, vacuum tables are great for this work, for sheet processing. So I'm going to grab all those circles, and this time we're going to use a pocket tool path instead of a profile. All right, and this is using a couple of mills. So I'm just going to remove all these, and then I'll say select. I just hit the remove button. Sorry, it went really fast there. But I'm not going to use any cutter, because you can use a larger cutter to remove most of the field, and then a smaller cutter to cut the corners by using, you know, multiple cutters, but we're not going to do that. And again, if we save this out, I wonder if I can do that. I know there's a way to do this, to save it out like this, but I'm not sure how to do it. This is version 11. It's changed a little bit, but I'm going to use the same cutter again. This is the end mill 3/4, still bit number 1. And it remembered all of those because I applied it and saved it all in here. It remembered everything that I had done before. Now, the reason, again, I'm going to, well, I haven't got to those other circles. I'm sorry. We'll get there in a second. So the cut depth is going to be the 0.76. We're going to use the end mill. It's going to do it in 3 passes, which is fine. We're going to use an offset, so it's going to cut in a circle instead of, and it'll start in the middle. I'll zoom in. It'll start in the center. It'll roll out so it gets to the outside. That's fine. Raster means it would cut back and forth like this and then cut around. I don't like this from the small diameter, so we're going to do an offset. And we'll ramp this. And in this one, because we are doing a pocket, we don't have any control over ramp other than the distance. We can't do a spiral. We're going to use the spiral on those other holes, which I'll show you in a second, because a profile toolpath will do that. A pocket will not. So in here, I'm going to make this a very short distance of 0.25. So it's going to come down pretty fast, but it will ramp okay. And then we'll call this pocket 1-inch holes. Calculate that. It's going to cut through, and now we'll preview. It's going to cut that same cutter, so it's just going to cut these first, and then it's going to go grab these and cut those next. And we can rearrange these toolpaths so we do it in any order we want. We can create it in any order, and then we can rearrange it if we'd like. Okay, let's drill all of our holes next. Okay, and this is an issue right here. This, we can actually leave that. I didn't realize this before, but because we're going to drill these with a drill bit, I don't need to have these crosshairs. So this is, we could have deleted those and done away with it. I didn't have to do those. Down here, though, we're going, because we're machining these out, I will need to do that. So let's create a circle right here. And I'm going to make the diameter 0.51, so just a little bit over ½ inch. And then if I put my mouse right there and click it, you can see how it created that circle. And so I'm going to do that for all of these. And again, that's why I created the crosshair. And I probably should have deleted that distorted circle first, but we can do that afterwards. It won't be as easy because there's 2 circles there and I got to make sure I select the right one. So it would have been smart to delete those first.
What are the crosshairs for?
Okay, the crosshairs are so when if I click out here, it creates that 0.51 inch diameter hole. And the original circle is this one here that was distorted. It's narrower, and I need it to be a full circle. So by using the crosshairs, I could just go here. Now that brings up another question though. The crosshairs may be totally whoops, let me create a circle here. I want to try something real quickly. I may have created more work than I need. So there it's distorted. And now if I say cut me a circle that's 0.51, oh, sure enough, it snaps right to the center of that. So I didn't need those crosshairs.
That's why
Okay.
I asked.
Oh, like I say, a lot of people have a lot more experience here than I've got and smarter
No,
than me.
no pun
Feel free to
intended.
jump in.
I was just curious because I jumped away to look at the
Right.
lead-ins, and I can show you that if you want me to show my screen. You can do a lead-in and a lead-out so you don't tear up your material.
Okay, let's do that. Let me finish this off and then I'll let you share your screen and you can show that. Okay. So let's see, we've got the circle there. I think we've got all the circles in here. And you're right, I didn't need the crosshairs at all. And that's good to know. All right. And I didn't need them up here at all either because we're just going to drill them. So forget the crosshairs.
You need to
But that one dummy
delete that
hole,
best hole.
Say that again.
you've got that
Oh,
one
delete this
dummy.
guy. Is that what you're talking about, that hole
That's
there?
what I was talking about.
Okay, let's delete that. All right, so I'm going to get rid of the crosshairs. I will, before I post this video, I will take the crosshairs out so that you don't have to worry about that. And this is going to take a minute. Oops.
Nope, wrong one.
Did the wrong one. And this is one of the reasons to leave the crosshair, actually, to be honest with you, because if I had deleted these circles first, then when I drop the circle in there, I wouldn't have to come in here and be careful to make sure I grab the inside one. So I guess there's advantages both ways.
Well,
You could have also put the new holes on a new layer.
Yep.
And then turned off that layer and removed all the other holes after you placed them and then
Oh
put it
yeah,
back on.
good thinking. That's the way. Yeah, I love layers. That's excellent. That's the best way to do it, actually. Okay, we're going to delete all these crosshairs. And again, before I post this with the video, I will get rid of all those. you know, while I'm at it, I'm going to get rid of these as well. It really won't matter for this class, but so Carl's in here tonight, and he explained to me that he and I are not OCD, we're CDO.
What is
Because
CDO?
everything CDO is OCD in the proper order.
Oh,
So that's what I am, CDO, and that's why I've got to fix this, or it's going to drive me nuts.
I'm the same way. That's why I brought up about why did you need the crosshairs? Because I draw in AutoCAD every day. So I'm like, what's he doing those for? It's just from the CAD experience, that's all. Less
Right,
clicks
okay.
and picks.
Right. Okay. So I've gotten rid of all of those. So we should be good to go. All right. So we've got these big cutouts done. Now, let's go ahead with this cutter in here. We're going to drill these holes. And again, if I just draw a square around them, I can select them very fastly instead of selecting them individually. The other ones we're going to drill. Okay, so that's all good. All right, now you're always going to be left in this preview mode, so you'll always have to hit close in order to get back to your thing. So I'm going to say use a profile toolpath. We're going to go to, and remembers 0.76. We'll use that. Remembers this cutter. We'll use that. Remembers that we did it on the inside. That's perfect. The only thing that we're going to do differently is we're going to add a ramp, but we're going to use a spiral ramp. Okay. Now, because this takes 3 passes, it's going to, each time it spirals around in a circle, it's going to go down 1/4 inch, and it's going to continue that to the bottom, and then it'll run all the way around the bottom, you know, at the bottom level, at the same level. So I love the spiral ramp when doing small holes and machining them out. And we'll call this, what do we call this? We'll call this the
Dowel holes.
yeah, dowel holes. There you go. So 2 L's or 1?
1.
Okay, let's fix that. So we'll have just 1 dowel holes. Okay, and we'll calculate that. Going to cut through, and we'll preview that just to make sure we got them all in here. That looks good. All right. Next thing we're going to do, we're going to pocket. Okay, let's turn the rabbet joints on as well. So we're going to select all of these. By the way, if you select them in a specific order, then you can tell it to cut in that same order. If you don't, it will kind of calculate its own, you know, use an algorithm to calculate what is considered to be the shortest tool path. But a lot of times I like to start at one end and work towards the other end instead of going all over the place. So your option, just know that that can be done. All right, we got to close our preview, and we're going to do a pocket because these are, you know, 1/4 inch bit. We got to machine them all out. So our cut depth's only going to be 1/8 inch. And we're going to use the same cutter. It's going to do it in 1 pass, and we're going to offset, although we could raster. Now we're not going to raster because these are on an angle. We're going to offset. And in this case, we're only going 1/8 inch. I'm not even going to use a ramp. We're just going to, well, all right, let's ramp, but we'll ramp 1/2 inch. Yeah, everything's big enough to do that. We'll ramp it just to save the cutter. And a pocket allowance. Now, pocket allowance will say you can make this just a little bit bigger or a little bit smaller if you need to. If you wanted to make sure these, you know, the parts fit in here, we might make it oversized. You know, pocket allowance maybe 10 thousandths or maybe 5 thousandths, 0.05. Okay.
You already did it with the circles though, ahead of time.
Yeah, I don't think we did it with these pieces here. Okay, so these are just the rabbet. Yeah, the rabbet. We're not doing any holes right now. We're just doing the this is a dado actually, and these are rabbits. And all we're doing is machining that out. And I want this one to be a little bit wider so that make sure the part fits in there. So we're going to go 0.05. Now, I can never remember if that's going to make it bigger or smaller. It's got to be a negative or a positive. So I'm going to call this
It's negative.
rabbit dado. Okay. All right. And here's how you can tell if it's negative, then this is not going to work. I'm going to go back to my 2D view, and it's showing the arrows in the actual tool path, but I can, I need to stretch this out because my zoom thing's in the way. So I can't see this. I'm going to have to resize this, make it a little bit smaller. So I'll come up here and click on this wireframe in solid. So now it's turned to a solid. You can see this is going to make it a smaller. So you were right, negative would fix that. This is going to make it tighter. So let's just double click on that and change that to a negative. All right, and then we'll calculate it and go back to our 2D path. And sure enough, you can see how it cuts outside the line, so it makes it slightly larger. All right, perfect.
By doing that with your rabbits, don't you throw the offset off for your horizontal pieces when you put them together, 10 thousandths off? I'm sorry, 5 thousandths off.
Say that one more time.
By putting that offset in the rabbits, you shifted the parts when you put them together 5 thousandths. Is that going to be an issue?
Well, by doing that offset, I made this, oh, the rabbit itself. Okay, so it's going to cut 5 thousandths of an inch deeper here. Pretty much irrelevant. You're gonna put that top piece across right there, and if it sits down 5 thousandths more, it's not a big deal. So in this case, I didn't worry about it. If you had to have this one land exactly on the line and not go over, then you would have to do these as separate, a rabbit and a dado, and you'd have to apply the allowance offset to the dado only. But in this case, it's not going to throw anything off. It's fine. Yeah, 5 thousandths is not a lot of material.
It just
Okay.
made everything a little sloppier, so it'll fit together
Yeah.
easier.
Yeah, the dados will all fit together, and of course the rabbits don't matter. You're just going to butt it up against that edge anyway, so that won't be sloppy because it'll go against the edge and get screwed in and glued in, so it'll be just dandy. But you will have a little bit of space to put these in, which, to be honest with you, if they're not perfectly tight, I don't care. They're captured inside of here, and they're put screws in here, so it doesn't matter, and they're not even visible. You can't see them at all, so that's all good.
So just to be clear, that 5 thousandths offset in those dados actually makes it 10 thousandths over.
Yeah, so it's 5 thousandths on this side, 5 thousandths on this side, so it's a total of 10 thousandths. You're right. And that's why on these rabbits, it's only picking up 5 thousandths on this edge because it's only cutting on this edge. This is overlap, so it doesn't matter if it goes out farther here. Okay. Now let me see. We've got to cut out our holes. We've got our pocket. We've got our dowels. We've got our rabbits. Let's preview the rabbits. Yeah, this is going to take a second. Simulating.
Doing rabbits on a nested-based machine like I was, it's always key that you check the, in this case, it doesn't matter when you're saying you're 10 thousandths over, but if it was going to matter, we would always have to check mic the material. And depending on the material, one bunk of material could be different than the next. When you start cutting you start cutting a couple hundred cabinets and you don't double check your material, you might not have, that's why a lot of shops don't do dados, because it can be a hassle.
Yeah. So we told this when we did the job setup, when we first created it, we said the Z0 was on the bottom so we could control how deep we cut into it.
Mhm.
And so if the material is not 3/4 of an inch, the depth of that rabbit and dado can be too shallow or too deep. In this case, we've got plenty of tolerance. It doesn't matter at all. But if that was, if you need to land those exactly right, well, then we might want to touch off on the top, either mic the material and set the material to the same, or simply set the Z0 on the top plane and touch the smart tool off the material. and then the depths of those would all be the same. But it might, and I would probably increase the amount we cut into the spoil board, you know, to make sure if it's thicker, we get all the way through.
What I'm
So-
referring to is the size of your dado. If your dado is too tight, your material is not going to fit, depending on where your material came from, whether it's, you know,
Oh, right.
19.05 millimeters, or is it 19 millimeters? That can make a big
I
difference.
see what you're saying.
That's what I'm saying.
So you're saying, yeah, the width of this obviously may not fit if the material is different thickness. So you'd have to mic it in order to create this.
Correct,
Okay,
correct.
perfect. Got it.
I'm just throwing it out there. In this case, it doesn't matter because you're making it bigger and you don't really care. But in a situation where you did care, you definitely have to always check the material before you even start cutting.
Oh, good point.
And
Excellent.
I second that with Patrick. I always mic my material before I do it. Otherwise, your cabinet's not going to end up the right size.
Right. Cabinets are a different story. The precision there is you want, you know, as perfect as possible. This one's a lot more forgiving, so we don't have to worry about it too much. So, all right. So you can see how we're coming together. We've cut our rabbets, our dados, our holes, cut out these various components here, you know, these cutouts like so. All right. So let's now go back and see what we've got left. We cut out the details, we pocketed the 1-inch holes, we cut the dowel holes, we rabbited the dados. All right, now let's say that we decide to drill these holes next. And so I'm going to select all the holes that we'll drill. And again, by going left to right, I can, you know, select these pretty quickly because it's only what's inside the box. And of course I could have done all of that, but, or you can just click on it like so. All right, let's catch these guys. And then we can catch all these. What do I have left? I have this. And, oh yeah, and I've got these at the bottom. Missed that last one. Okay, so now I've got all my, oh no, I don't have these holes selected. All right. So we'll close our preview, and this time we'll use the drilling toolpath. And now you're probably going to drill. We are going to have to change. You're going to drill with a drill bit, not with a 1/4 inch. If I drilled with the 1/4 inch, of course, we have a 1/4 inch hole, the screws would go right through. So we're going to change this. Now, a drill bit is not flat on the end. It's got a little bit of a, you know, point on an angle. So I'm going to go a little bit deeper. We'll drill deeper into our spoil board to make sure we get the straight edges of the drill bit all the way through. So I'm going to go maybe 0.775. What did I put? I didn't put point. 0. See, this is where I need my glasses so I can see what I'm doing. And I can't see it, so I'm going to erase it. I'm going to do it again. 0.775. Okay. All right, and we're going to select, this time we're going to go to our drill bits. Okay, so here's an 1/8 inch, here's a 5/32. Now, the thing that's nice about the spindles, the little one has an ER20 collet. The big machines have a ER32. You can get collets that'll hold drill bits or router bits, metric or imperial. So you would need a collet to do this. Let's say we're going to drill out to 5/32 of an inch or 3/16. I would change this to number 2. And this has 2 flutes in it. And we can say our cutting parameters, our cut depth is 1/4 of an inch. And we're only going to spin it about 4,000 RPM, all right, inches per minute. And our plunge rate is going to be 30 inches a minute. Okay, so we're going to go ahead and apply that and select it.
Tracy, real quick, if you were to use brad points, would the settings be close to the same? Have you had any experience with them?
Brad points, the tip of it comes down just a little bit, so you would have to still drill through the material a little bit, but I like brad points because they don't drift. But so you don't need as much depth cutting through because the brad itself just barely cuts, points through a little bit. So I like those.
Do
Go
the
ahead.
RPMs, would you set the RPMs about the same as a standard bit?
No, the standard bit's going to be much higher. When I'm drilling with a drill bit, I never want to go slower because of the spindle. I don't want to go slower than about 3,000 RPM. So you'd set it at about maximum 5,000 RPM. If I'm using a little tiny spindle, I have to set it up a little bit higher or else it can stall on bigger bits. Small bits won't matter, but little bits or big bits, I need to be real careful. And I might peck it and make multiple passes. You just don't want to overload the bit. So this says it's going to be use peck drilling. We're going to do that. And we're going to extract it of the height of the previous pass. Now we're going to retract it a gap of 0.125. So it'll retract it, lift all the chips out of the hole, and then it'll plunge back down. That's what peck drilling is, a little bit at a time, and it'll go down that 1/4 of an inch for each peck. And if you want to, you can have it dwell. I never have, don't think need to. And you can also select the vector order, so it'll cut in the order that you selected them. Otherwise, just let it calculate its own. And we'll call this drill. I'm just going to say drill holes. This is the assembly holes, but that's fine.
I usually, when I label that, I put in the size of the drill bit. So when I get it,
Oh, yeah, good point. Yeah, good point. So we could put the size here, and you can just right click here and say rename it. And we were doing 5/16. Drill 5/16.
That won't work.
Oh, I'm sorry. Yeah, you're right. 5/32. Yeah, nice sketch. I had young man cataracts. I think they came from basketball injuries, but I was going blind, and so they changed my lenses. It took about 10 minutes, and they said you can either have far vision or near vision. You can't both. So I picked far vision so I don't have to drive the glasses. So I have 20/15 vision, but I cannot see my computer. This kind of sucks. I have to have reading glasses for this, and I didn't bring them. All right, so we've drilled all of our holes. All right. And now the last thing is cutting out our parts. So let's just select all the parts we're going to cut out. Close our preview and go to our profile toolpath. We're going to cut on the outside of all of these lines. We're going to cut the 0.76. We're going to use the 1/4 inch end mill, same thing. I'm going to change the passes to 2 instead of 3. We'll do a separate last pass, again, of 15 thousandths. And if you wanted to, you could add tabs. I don't think it's necessary. You might want to do it on the little pieces. So let's just do that. You click on Edit Tabs, this button right here, and then you can just click on where you want to put those tabs. These pieces up here are all going to...
You didn't use 15th. You have a 005.
Oh, I used 5 thousandths?
Up one.
Separate last pass.
Oh, separate last pass. Thank you. Okay. Somebody's got eyes and can see what I'm doing. That's nice. All right.
You'd
All
save
right,
yourself
so-
a lot of heartache if you just get an extra pair of glasses and leave them there.
I know. I need like 8 pair. I just put them on every desk and every computer and everywhere I go. Okay. Now, real quickly, I'm going to use a 3D tab. And you can see this little icon here. It like ramps, it's like a speed bump. It ramps up and down. If you turn that off, it's gonna stop right here, and it's gonna raise the bit, then move over, stop, and plunge back down. You're gonna find witness lines right here, which I hate. It's more standing. So use a 3D tab, and then you can just say it's not going to require much at all of a tab to hold us in place because we're putting the sawdust back in the groove. So I'm going to say make this only 0.375, and I'll go 1/8 of an inch high. So it'll just be a little speed bump right there that you can break out real easily. And we're going to ramp these, and we're going to use a smooth 20-degree angle because we're cutting out bigger parts. Whoops, clicked on the wrong screen. All right, and then we'll just say here, cut out parts. All right, let's preview this and see if we've got everything done. Oh, I can speed this up. Right. And of course, all these will come out. Now, normally I could click on this big material and erase it, but because I put these tabs on, it would erase these parts as well. So we won't do that because you got tabs here and here. On the smaller parts, I put those tabs.
Without the tabs, after you cut those at first cut, you need to remove those, don't you?
The tabs?
No, there are no tabs the way you've done it. I only
put tabs on this part here and on this
Do you
part.
want to leave the cutouts, pieces of wood in there for all the rest of the cutting you're doing?
All right, good point. Now we'll always cut out the part last. So we've done all of the work first, then we simply cut out the parts, and we leave those in until it's all done, and then we'll just pull the parts out.
And it's on a vacuum table.
It's on a vacuum table, so everything's going to be held in place. Like I said, I've cut several of these. This works beautifully. Okay, the only problem I have here is that we use the 1/4-inch bit for every operation except for the drilling. So this would have me change right here. So what I'm going to do, I don't want to change to a drill and then back to the 1/4-inch. So I'm simply going to push the drilling to the very beginning. And that's what I would do first. In fact, I would probably put the rabbit and the dados, and I misspelled it, next, because those are just making real light cuts. Then I might, cut up my dowels. So those are kind of small. My cutout parts are going to be last. Pocket the holes I might put up here. Then cut out the details. These are larger, so I do those second to last, and then cut out the parts last. Okay, so now if I reset my preview, we can kind of zoom in on this. Maybe I'll set it up like this. Let me close this out so we can use more real estate here.
Move your drill bit back up top.
Oh, did I? Oh, yeah, you're right, I did. Okay, so rabbit, then there are rabbits, then there are, okay, so this is the order I want to do this in. Now, if I say preview all toolpaths, it's going to go pretty fast, but okay, so the last thing it did was cut out the parts. And then these, of course, we'll just pull the whole parts out and start assembling. Okay, any questions?
Yeah, Tracy, what's going to hold your 1-inch dowel in place to keep it from falling through?
Oh, good question. I'll show you what I did. I got a 1-inch shaft collar. It's, let me turn this layer back on. This is an assembly. So right here, you notice that I had it come above here 1/2 inch and below 1/2 inch. And so I'll put the shaft collar right on here. It's the idea of the shaft collar is 1 inch. So when I clamp it on, you don't need one at the bottom. You could if you wanted to, but you don't need it. Just put one on the top and clamp it on, and it's done.
Did you put your spacer washer both top and bottom?
I did, and I didn't bother to do this here. I will post the file, but it's pretty simple. I used, I can't do it in this file because it's a different material, but I simply cut a couple of circles. And so I said, let's cut a 3-inch diameter circle here and here. Oops, that went back to 1 inch. Okay, so this one here is 3. This one's only 1. Let's move this to the center of it. Okay, and so I cut out the 1-inch diameter hole and then cut out this. And when I cut this one, I did use a tab on this outer side piece because I didn't want it to grab and jump because it's pretty small. And I did not use a vacuum. Yeah, maybe I did use a vacuum table. The sheet that I had is only 12 inches by 12 inches. So I don't think I used a vacuum table to cut that. I just stuck it down with double-sided tape and then cut it out. So I did use tabs. And again, I bought that material on Amazon. It's the 1/8-inch plastic, and that worked extremely well. It was a white, I don't know what type of material it was, to be honest with you, but it works really well.
I'm cheap. I would have used a piece of milk jug.
Yeah, I mean, seriously, you could use a piece of, you could make that 1/4 inch instead of 1/8 inch, and you could use a piece of, 1/4 inch MDF, and it would work. Especially if you sprayed that with a little Dynaglide, when you assemble it, that thing would spin like crazy. So you don't need to use the plastic ordered in. You can use virtually any material, especially if you wax it with the Dynaglide. Okay, I'm going to go ahead and save this then. Now I'm going to post this file and the other file, and I'm going to post the error codes. So I'll look for Milo. He was going to send them to me, so I'll post those on the site. I'll have to create PDFs out of it unless he sends me a PDF. And then I'll post all of these so that you can pretty much make this any way that you want, any size that you want to go. Okay, any questions?
Yeah, post
Tracy,
them as DXF as well, please.
Oh, DXF these drawings. Oh, that's right. That's right, because older versions can't open it. Okay, anything else?
yeah, I did an arm like that out of PVC, and the problem I had was initially my hose came down behind the gantry, and because I've got the lower profile dust shoe on it, I actually have to have it in front, otherwise it gets tangled up on the gantry. How would you measure this one for that same purpose?
Use a 3x5 or a 4x8.
A 3x5.
Do you have the CNC dust shoe on it?
Yes, I do.
All right. Just real quickly, here's what I do. I always draw the size of my table that I'm going to cut. And let's say that I'm only going to cut on the standard table that's on there, which is only 48 inches long by 24 wide. It's actually 49. Now, if you extend the table and make it bigger, of course, you would draw that table. Okay, and then I calculate how far away from the wall it is. So let's say the wall is right here. Okay, then if you create a pivot point right here, you need to swing, when the gantry is all the way back here, your hose is going to be here, here, and at this end it'll be here and here. But back here it doesn't go all the way, well, it can go all the way back because the table is farther. So yeah, let's say you want to go to all 4 corners. Then, just calculate that with that distance away from the wall, you're going to have an arc. So let's do something like this. Let's say the arc is, oh, I didn't do circle, sorry.
Problem I had was when I used the turning station, the hose was actually behind, and it got hung up on the spindle and popped a screw off of it.
How is it behind the gantry? Is it draped down behind the gantry?
Yeah, because the hose actually came from the wall straight across the center of the bed. And when your spindle is in the forward position like that, the hose actually drapes over the top.
Okay, so you're not using a swing arm, you just have it pinned at one point on top?
Yeah, originally. So I'm going to try the swing arm. I like the idea of it. I'm just kind of cautious about where I'm going to hang that thing.
Yes, the swing
Well,
arm makes it, oh, go ahead.
I have the same kind of question with using that cant. You had several people who build some kind of a shelf at the top, run the hose up through it, and connect it to the top of the spindle, so you don't end up having the gantry problem that he's got.
Oh, I see.
So
Yeah,
how do you connect it to the spindle?
Okay, I was actually just out in Colorado, and what Milo does is on the Z-axis assembly, he actually bolted a piece of I think it was just aluminum piece that stood straight up, and then he's able to attach the hose to that so it holds it up above it, out of the way. So that that's a possibility if you need to have something hold it up out of the way. If you put a swing arm like this, the hose can be very short, and you'll probably eliminate that problem completely.
Tracy,
Yeah.
this is Dean Martin. I made a dust collector, and my arm does not swing. I went to Rockler and got a hose that was stretchable, and so that when it comes back, moves around, it stretches the hose, or when it gets to where it needs to be shorter, it collapses.
It collapses. And you got that from Rockler, you say?
Yes.
All right, perfect.
One thing
That's what my hose is.
One thing you want to be careful, and it says it, Kent says it on their website, is that you've got to have some kind of stress reliever, because if you're just draping your hose in the first, or if all the weight's being held by that acrylic, it can be hard on the acrylic. What I did, because I was cheap and in a hurry, I just took a piece of rope and wrapped it around my Z axis motor and wrapped that around the top of the hose, and that actually kept it controlled enough. Didn't require a whole lot of work. It was just something to get me by temporarily, and that temporary turned out forever.
Nice.
I used the same one from Rockler, and it works great. It just it's very flexible.
Is that from Rockler? Is that a 4-inch hose, or do they have it in bigger diameters?
It is 4-inch hose.
4-inch. Okay.
Yeah, I want a 3x5.
Yeah, mine was a 4-inch hose also.
Yeah, on my 3x5, I use a 4-inch hose, and that works great. On the big machine, because I'm doing a lot of work removing a ton of material, I decided to go to the the 6 or the 5-inch. I may have gotten away with the 4. I don't know. I didn't test it, but I decided just go bigger, just in case. Just overkill. I'm a guy, so overkill.
Hey, Tracy, that website I told you guys about last meeting, Blastgate CO, blastgatecompany.com, that ball joint that I put on the top of mine works really well. And they can fabricate anything you need real quickly. They're really good. So it's blastgateco.com, and they might be able to help these guys out if they need an extension with a ball joint on the top. That'll eliminate the problem.
Excellent.
And I
You still need to connect the ball joint at the top of the gantry, or it will catch.
Mm-hmm.
So then you've got to do something to tie it to the top, or some of them have made a wooden slat that goes across it, and then they change the screw size on the top of the spindle to hold that holder on.
Yeah, so that on a 3x5 where the cant shoe is hanging out the front and the hose is clear down at the bottom, it's a different animal than the 4x8 where it has the dust manifold and you're pulling it off the top. So on the 4x8, it's pretty much taken care of for you. The 3x5 is where you start, introducing this problem. And like I say, if you mine was really simple, just a piece of material that extended up, and he just I don't know if he zip tied it or taped it or what he did to attach it to that, and that solved his problem.
That's what I did as well. Have a straight piece of dust collection pipe to get above the gantry, and I actually machined out of wood a piece of bracket that I screwed to the top of the mount, the spindle mount, and so the hose is above the gantry.
Did you drill new hose? Did you drill new holes or use longer screws on the existing hole?
Yeah, yeah. I don't know if you caught that question, but did you drill new holes and attach that, or did you use the screws, replace the shorter screws with something on the machine and put longer screws to secure it?
Okay, I understand the question. No, we drilled holes, actually tapped them, and screwed a little bracket to the tapped holes.
I'm pretty sure that's what Milo did as well, if I remember right. Milo, if I'm mistaken, you can jump in and correct me.
I just had a piece of aluminum extrusion that I had laying around and just got it up high enough to clear the motor, and it doesn't pinch when it hits edge to edge. I would usually pinch the hose over by the turning center.
Okay,
And then just
good.
zip tied it to that, and quick kill.
Excellent. Well, okay, in this class tonight, we did the swing arm. A lot of people have asked about it when they saw ours. This is not the only answer. It is an answer and a method that works extremely well. So if you want to use something different, obviously that's legit. But the reason I wanted to teach this class was not only so that we could show you how to build a swing arm for yourself, but we also wanted to look at a couple of techniques. So just recapping the techniques that are really powerful that we used here is by adding nodes and cutting these vectors, we were able to stretch or resize it, and the width stayed the same. It's just the length gets longer or shorter. So you can modify a part. You just select the components you want to compress or expand and deselect the others, which is kind of an advanced technique, but it's pretty awesome. The other thing, we showed you several different milling techniques using a spiral ramp versus an angled ramp, versus drilling and so on. So hopefully this helps you not only with this type of project, but within your just, general practice of creating tool paths for various parts as well. All right, any other questions before we call it good?
This
Yeah,
is
Tracy,
Jim.
I have
just got
a
quick question.
Okay, we got a couple. Let's just take one at a time. Go ahead. Somebody jump in.
All right, Tracy, I have an off-topic question.
You bet.
And this goes back to the display table.
Okay.
When you were talking about importing files from Aspire into CCAM Pro,
Correct.
you said they were transferred as an NC file. The Maverick or the Mach 3 doesn't have a post processor that saves as NC files.
Okay, so here's what you're doing. NC file and a text file are, from Mach 3, they're all text files. It's just the extension is different. So when you import it, you're looking for the NC file, but once you import it, it's going to kick it out as a file of either NC or TXT. Okay, so it doesn't matter what it comes in as, but you're going to have to when you select it, you're going to have to navigate it to grab that particular file. And again, it may be text or it may be NC. It's irrelevant. It doesn't matter. It's going to bring it in, resample, and kick it out what it needs. All right. So you won't have mixed files. In other words, part of it won't be, because it's going to be one document. It's impossible to have a document that has NC and TXT extensions because there's only one document. It's going to have one extension. So you really don't have to worry about that. Just select the file. But keep in mind that it may be .nc instead of .txt. It could be the one.
Well, it's a .txt file, but when I try to bring it in CCAM Pro, I get an error and it just closes the program.
What does the error say? Can you tell me?
It's an unhandled exception, and then it's got a paragraph of stuff.
Okay, we need to look at that. And to be honest with you, if you use the form, it's legacycnc.com/CCAM, CCAM. That's a form where you can input all of your errors or questions or comments. And then Mike, who does most of the program, not on most, he does all the programming for it, will be able to look through that, and we can then discuss how we approach and fix a problem. So that's the best thing to do, is use that again.
I did that. I
Okay.
put that in there, but I'm kind of stuck. I'd like to finish the project, but I can't. So that's why I'm asking you.
All right, let me see if I can recreate it. Would you drop me an email then directly with your files that you're trying to import? And let me see if I can recreate it here and see what we have to do to fix it for you.
Try renaming the file with the TXT extension instead of MC or NC.
Yeah, you can always rename the extension. And that might fix it. That might be the easy way to take care of it right now.
Tracy, it's Norm. I need to give you a real quick call after the meeting, if that's okay. Kind of important.
Yeah, just call my cell. That's fine.
Yep, I got your number.
Tracy, this is Jim. Did you get your airplane ticket?
I did. I've got the itinerary. I'm flying out Friday night. I will send you. You want me to just email you the times?
Yes. You got my
Okay,
stuff.
we'll do.
Yep.
Okay, we'll do. Okay.
Tracy, I've tried to call up and order the CCAM, but I keep getting John's voicemail, which, by the way, happens to have a message from last July, but I can't get to
Cindy?
Cindy. Yeah.
She actually has a direct number. When you call in, you get the basically the phone tree that lets you go to different extensions.
No, actually, it's the basic message that says, "Here's our hours," and then it goes right into John's voicemail. I must be dialing the wrong number.
What number are you dialing? Do you know? Can you tell me?
Just a second.
Tracy, you want me to show you that lead-in thing?
Oh yeah, thank you for reminding me. Let me set it up so that you can share real quickly.
Okay, 801-609-2805.
That's why that's John's direct extension. So you got a pencil? Write down this number. You ready?
1 second.
Okay.
Go for it.
801-491-0010. That'll take you to the phone tree, and then you can go to logistics, which is Cindy. And if you're going to order parts or check on shipping, anything like that, it's logistics, and that will be Cindy. Okay. All right, show me your ramp here. Everybody can see this on the screen?
When you create a profile or a rectangle, and if you go in and you highlight your squares or your vectors and you hit N for node, it's going to give you your start point. So if you want to do a lead in from the inside, a lead in and a lead out, if you're using a compression bit, you're going to need to go in, you're going to need to click on this, right click, and insert a point. And then change this point to the start point. Now you got the two start points. Now when you go into your leads, you can go into leads, you can change this to whatever you want. You can have it as a lead in length and whatever radiuses you want. Then when you calculate it, it's going to, let's see, reset preview. Now it's going to lead in from the inside and it's going to lead out from the inside.
Right, okay. So if you were cutting on the outside of the vector, it would probably lead in from the outside.
Yeah, so if I go and change that to the outside and I recalculate it, it's going to lead in from the outside.
Perfect. Wow. Thank you very much. Learned something new.
What's the
Go ahead.
I'm sorry. What's the value of that?
So if you're using a compression bit, your compression bit on the bottom of your bit, you have about 1/4 inch of an upcut. If you just drop it in straight, it's going to tear up your material. So you lead in from waste material into your good part, whether you're leading in or you're leading out.
Got it. Thank you.
Yep, you're welcome. I'm going to stop sharing.
Yep. It also won't leave a witness mark.
And it won't leave a witness mark. And that some of the bigger machines I've worked on the industrial side, where when I was at the school, they have that kind of built in, a lot of that stuff. You don't have to go in all the time. It depends on how you have the system set up. But that's when you're doing the same thing over and over again.
They also use that for plasma cutters
Correct.
because they leave burnt marks, so they'll lead in from the inside and come out to the outside.
Yep, correct. You're basically, you're destroying your waste material instead of your good piece. Especially when you're leading in with a compression bit, or just about any bit. You actually will get a better cut if you do a lead in. Sometimes you'll see the mark where you just plunge. Because you have, sometimes we're using a quarter inch or even an 1/8 inch bit. I've seen it with an 1/8 inch bit, you can see a little cut on the inside if you don't lead in.
Excellent. Thank you for that tip and that information. That's awesome.
I haven't had a chance to verify it, but last time I did this, it did the lead in until it went to the last pass, which I did a last pass offset by 1 thou or something. And on that last pass, it went straight down and left the witness mark. So if you're doing this, don't do the last pass. Or, I mean, I haven't verified it yet. It's only done it to me once, but that was what happened to me. So
I'll look into that. That might be something to email Vectric on, because that sounds like a Vectric thing. If it's not, if you're telling you want it to do lead-ins, I don't see why it wouldn't. It should do a lead-in on every pass, even that last pass. So that might be a vector hiccup or something they just didn't accommodate for.
And if you find something like that that is a Vectric issue, you can contact Vectric and let them know and emphasize the importance. They'll build it into the next update. And they do periodic updates before they get to, yearly they upgrade the whole thing. Semi-annually they do a major upgrade, but there can be upgrades in between. I know that I was just talking with Milo and he had found an error and sent it to them and they fixed it on the update.
Tracy, speaking of updates, are there any updates for CCAM Pro?
There is. What I'm waiting for right now is to get so I can do, go to the help and click on add-ins so that you can simply update your system from a file. Because I've got quite a few people, and if I have to go in and copy files into every single one, it'll take me forever. So there is one that we're doing, and there'll be more coming, but I've got to work with my programmer and get that fixed so that makes it easy to upgrade in the future. Anybody else?
Tracy, would you have time for 2 phone calls after?
Sure. Yeah, if you call and I don't answer, it just means I'm on the line. So just wait a few minutes and call back again.
Great, thank you. Won't take long.
I won't either, Alan.
Okay, great.
Thank you, Tracy. Good meeting you this weekend.
Right.
Don't forget to send me your itinerary. This is
all
Jim.
Right. Yeah, Jim, we got it.
I'll be looking for that tonight.
Okay, sounds good.
Thank you for the invite.
Thank you.
All right. All right. Good night, everybody.